To convert European wire sizes from square millimeters to square inches, refer to the following conversion chart. This chart provides a direct comparison between the European standard millimeter square measurement and the equivalent area in square inches. This is useful for understanding wire capacity and ensuring appropriate wiring is selected for electrical applications. The European size of 0.5 square millimeters is equivalent to 0.78 square inches. The European size of 0.75 square millimeters is equivalent to 0.136 square inches. The European size of 1.0 square millimeters is equivalent to 0.196 square inches. The European size of 1.5 square millimeters is equivalent to 0.295 square inches. The European size of 2.5 square millimeters is equivalent to 0.493 square inches. The European size of 4.0 square millimeters is equivalent to 0.785 square inches. The European size of 6.0 square millimeters is equivalent to 0.118 square inches. The European size of 10.0 square millimeters is equivalent to 0.197 square inches. The European size of 16.0 square millimeters is equivalent to 0.314 square inches. The European size of 25.0 square millimeters is equivalent to 0.492 square inches. The European size of 35.0 square millimeters is equivalent to 0.688 square inches. The European size of 50.0 square millimeters is equivalent to 0.982 square inches. The European size of 70.0 square millimeters is equivalent to 1.378 square inches. The European size of 95.0 square millimeters is equivalent to 1.870 square inches. The European size of 120.0 square millimeters is equivalent to 2.362 square inches. The European size of 150.0 square millimeters is equivalent to 2.953 square inches. The European size of 185.0 square millimeters is equivalent to 3.643 square inches. The European size of 240.0 square millimeters is equivalent to 4.724 square inches. The European size of 300.0 square millimeters is equivalent to 5.906 square inches. The European size of 400.0 square millimeters is equivalent to 7.854 square inches. Finally, the European size of 500.0 square millimeters is equivalent to 9.820 square inches. Using this information, you can correctly convert between European wire sizes and their equivalent in square inches. Understanding wire sizing is an important element when working with electrical systems. Selecting the proper wire gauge is critical for safety and performance. Undersized wires can overheat, potentially causing fires, while oversized wires can be unnecessarily expensive and difficult to work with. Several factors influence the appropriate wire size for a given application, including the amperage the wire will carry, the voltage drop allowed over the length of the wire, and the ambient temperature in which the wire will be installed. Electrical codes, such as the National Electrical Code, or NEC, provide guidelines and tables to help determine the correct wire size for various applications. These codes specify the maximum allowable ampacity for different wire gauges and insulation types. Ampacity refers to the current carrying capacity of a wire, typically measured in amps. It's important to consult these tables and follow the recommendations provided to ensure electrical safety and code compliance. When working with electrical systems, it's crucial to consider the voltage drop that occurs over the length of the wire. Voltage drop is the decrease in voltage from the source to the load caused by the resistance of the wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. To minimize voltage drop, it's often necessary to increase the wire size, especially for long runs. The ambient temperature in which the wire is installed also affects its ampacity. Higher ambient temperatures reduce the wire's ability to dissipate heat, which can lead to overheating. The NEC provides correction factors to adjust the ampacity of wires based on ambient temperature. These correction factors should be applied to ensure that the wire is not overloaded. In addition to the factors mentioned above, other considerations may influence wire size selection, such as the type of insulation, the number of conductors in a raceway or cable, and the presence of harmonics in the electrical system. Always consult the NEC and other relevant standards to ensure that the correct wire size is selected for a particular application. When selecting wire, it's also important to consider the type of conductor material. Copper and aluminum are the most common conductor materials used in electrical wiring. Copper has a higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is lighter and less expensive than copper. For a given ampacity, an aluminum conductor will typically need to be larger than a copper conductor. The NEC provides tables that specify the allowable ampacities for both copper and aluminum conductors. When working with aluminum conductors, it's important to use connectors and terminations that are specifically designed for aluminum. Aluminum forms an oxide layer on its surface that can increase resistance and lead to overheating. Special connectors and terminations are designed to break through this oxide layer and provide a good electrical connection. Proper installation techniques are also important when working with aluminum conductors. Aluminum is more susceptible to loosening under vibration or thermal cycling than copper. Therefore, it's important to tighten connections properly and to use antioxidant compounds to prevent corrosion. In summary, selecting the correct wire size is crucial for electrical safety and performance. Factors to consider include the amperage, voltage drop, ambient temperature, conductor material, and applicable electrical codes and standards. Always consult the NEC and other relevant resources to ensure that the wire size is appropriate for the application.